All right, welcome to 7th grade virtual session. We are going to go over some course expectations and we're going to talk about some of the content that's going to be in Module 4, just a little preview about it. So I'm going to share my screen here and get away from this stuff. Okay, there we go. So, Module 4, Overview and Course Expectations. We're going to review course expectations. Oh, I actually put Module 1 here. That's a mistake. Overview of Module 4 topics, because we're in Module 4. Even though it feels like Module 1 because it's the beginning of the semester. So, course expectations. Try to attend at least one middle school lab in person. I know some of you guys who are here right now have already attended one, so that's awesome. Just so you can get that hands-on experience, right? You can interact and have fun with other people in middle school. However, you do have to turn in 2 labs by the end of the semester. There's going to be 4. One of them already happened. We have 3 left. You can always go back and watch the videos. So I'm going to show you how to do that in a moment. Virtual sessions, attend them. And if you can't, let me know why, because then you can always sign up. You can always click on the recording and watch it after, but it's not quite the same. Read the lessons, guys. I've noticed some people are going straight to the assignment, doing the assignment, and then they're not getting it right because they didn't read the lesson. So read the lessons. That's why they're there. The answers are in the lesson, I'm telling you. They're always in the lesson. Take notes. When we do our oral exams, you get to use your notes. When you take your test, you get to use your notes. So there's no reason to not have tons of notes to look at. And I'm probably going to be doing, for our next virtual session, we're probably actually going to do how to take notes. We're going to pick a lesson, and I'm going to show you guys how I would take notes for it. Obviously, there's many ways that you could take notes, but that way people get an idea of how much they should be writing. Also, ask me questions, right? If you don't know how to do something, you don't understand what something means, send me an email, send me a text, just say, hey, I'm confused on lesson 4.05. I don't understand this. Make sure you tell me the lesson, because otherwise I'm going to be like, what are you confused on? I don't understand. Okay, and so we're going to quickly review Canvas here. Just a couple of things that I added this time. So the calendar, right? Hopefully everyone has seen the calendar. Here we are right now, 9 a.m., 7th grade virtual session. Right, tomorrow I have a virtual session for 6th grade, so that doesn't apply to you. And then if you go to the next month here, March, our next middle school lab is on March 17th on St. Patrick's Day. And we're going to be doing a lab with bubbles. And I'm not going to tell you anything else, but it's going to be fun. It involves blowing bubbles and changing some things about the bubbles to try to get them to live longer. So it should be fun. Okay. In modules, I also added a module at the very end called Labs and Virtual Sessions. This is where you can turn in your 2 labs. You can pick to turn them in at any time, right? Even though the due date's not going to be until like June. And this is where you'll find your information, like the DNA extraction lab. That was the first lab we did. So if you click on that, it's actually going to give you the PowerPoint that we looked at. There's the lab sheet and there's a video. So everything you need is right there. I didn't put tons of writing because I figured once you open the lab sheet, there's tons of writing. And then there's a video, and there's Emma right there in the video thumbnail because she was the one who was a nice partner to the virtual attendees. Okay, so again, this virtual session right now, you're going to find the PowerPoint I have posted already on modules, and I'm going to post the video there. So anytime you miss something or you want to go back and look at it again, Everything is going to be posted in that labs and virtual section part of modules. It's at the very bottom. Okay. Otherwise, let's go back to this. So I made a change on grade percentages this time. So exams and projects are going to be 50% of your grade. So if you need a retake on an exam, send me an email. Say, I didn't do well, I didn't study enough, I forgot my notes, I couldn't use them, something like that, and I'm happy to let you take it again, as long as you have notes. Assignments and labs are going to be 40% of your grade, and then the oral exams are 10% of your grade. Hopefully that will encourage more people to do them. We can do them during the middle school lab, or we can do them on the phone. So just email me when you want to do yours, and we can set that up. All right, so Module 1, key topics. A lot of you guys are already deep in, Module 4. I keep saying 1. A lot of you guys are already deep into Module 4 here. Turning in, your 4th or 5th assignment already. But regardless, these are the key topics from Module 4. We had weathering, erosion, the rock cycle, fossils, absolute dating, relative dating. And then they also go into human impact on the environment, right, which I'm not going to include here, but is important. Hold on, my dog is going to make a lot of noise right now. Okay. Whenever I do virtual sessions, my dog thinks that it's playtime, and he gets super excited, and he runs around and plays with everything. So these are just some quick definitions here that we're going to want to look at. How do I get out of Emma and onto me? Huh, weird. Okay, the vocab, which I got away from. We got weathering, erosion, rock cycle, fossils, absolute dating, and relative dating. I'm just going to really quickly say what those things are, and then we're going to kind of go deeper into a few of them. So weathering and erosion are both the breakdown of rock. The only difference is that with erosion, that rock gets moved to another location. With weathering, it just breaks apart and stays there. The rock cycle, oh, no problem, Carlo. All right, the rock cycle is heat and pressure and melting that can cause rocks to change between the 3 types of rocks, right? It's basically, we'll see, it's a picture, essentially, that shows us what happens to rocks when we put heat and pressure, when they melt, when they erode. We also have fossils in this module, which is probably, in my opinion, the most exciting part of it, because rocks can be kind of boring sometimes. Bones or other hard parts of an animal that get molded into rock, right? That's a really simplified definition for fossil. And then we have our absolute and relative dating, which actually tells us how old a rock or a fossil is. So our absolute dating, I'll just explain it now. You actually use carbon, and you use the half-life of a radioactive carbon molecule to figure out how old the rock is. So they use chemistry, basically, to figure out the exact age, and they can get it down to years. They might even be able to get it down to months. Relative dating is just kind of like the general age. Oh, well, it's, in this time period or this many years old. And they do relative dating based on where the rock was found. Right? Was it found super deep in the earth? Was it found on top of the earth? Right? And how old were those rocks? So just 2 kinds here. We have a really specific one, and then one that's kind of like, well, it's probably this. So why do weathering and erosion matter? Here's why, I will tell you. I really want to be able to see my face. I don't know how to do that. I guess I'll go back to this. Okay. So plants can cause weathering, but they prevent erosion. It sounds like a contradictory statement. Plants can cause weathering, but they prevent erosion. I want you to think about that for a second. And either just keep it in your mind, or if you can, type it in the chat what you think that means. Why can plants cause weathering, but they prevent erosion? All right. So I'm guessing people are thinking about this, right? Because I don't see anyone typing yet. So weathering is just the breaking of rock. So in this middle picture here, we actually see weathering happening. There's a tree here, and the tree root cracked this concrete wall in half, right? Which is probably annoying if that's your wall and you wanted it to be a wall. But regardless, that's not going to cause any serious issues, right? It just cracked a wall. That's not even for a building or anything. If it was a building, then we're talking maybe a problem. But plant roots are in the ground. They're actually holding on to soil. So plants actually prevent soil and rock and dirt from moving away, right? They might break the rock up, but they don't let the rock move. And that's super important because if you take away all the plants, so if the person who built this wall had destroyed all of these trees back here, all of that soil and rock would have been able to get pushed away just by rain, right, naturally over time. And then you would have serious problems over here with the soil and the land. You'd probably never be able to plant over there again, right? And eventually this wall is probably going to get weathered and eroded and completely destroyed. So plants actually hold on to soil, right? Think of their roots like hands. They're like holding the soil. All right, we also have acid rain, which is when the rain mixes with carbon dioxide in the air and other substances, it can actually form an acid, and then it falls down as an acid. Now, we're not talking crazy acid here, right? Like the strongest acid you probably encounter is your stomach acid. If you've ever thrown up, right, you experience that terrible burning. The rain is not that strong. It's just a tiny bit of an acid. And we talked about acids in our last, or 2 labs ago, I believe, when we talked about pH a little bit. So acid rain is usually like a pH of 6. It's pretty close to being neutral, but it's a little bit acidic. So it doesn't rain and then just kill everything, right? That would be extreme. Really what happens is over time, it continues to cause issues. So the Statue of Liberty was actually something, and a lot of statues and monuments that have been destroyed by acid rain, right? Where this acid caused a reaction in the copper so that it oxidized and became this green color. So the Statue of Liberty originally looked like this. It was copper. That's how it came. And then over time, now we see it's completely this bluish green color, right? If you look up close at it, there's not pockets of it that are even copper. And that's because of weathering and erosion via acid rain. All right, and then otherwise, I kind of already said this, erosion can destroy ecosystems and kill plants and animals, right? If the soil is constantly getting pushed away and there's no soil left, plants can't take root, they can't grow, and then if there's no plants, there's no animals, right? So too much erosion is a bad thing. But erosion is also cool because it makes awesome rock sculptures like this guy here, where it's just amazing that someone was able to take a picture of this, and you would think, oh, humans probably carved that. No, right? That was from water. Water created this insane rock structure. It's pretty powerful. All right, so quick switch of topic here. We're going to the 3 types of rock. Some of you guys might already be in this one, some of you may not. So we have metamorphic, sedimentary, and igneous. Those are the 3 main types, right? They have tons of subtypes and tons of examples of each one. Metamorphic rock is the rock that's formed from pressure and heat deep in the earth. It usually looks ribbon-like. So we'll see a picture of what that looks like in a second. Sedimentary rock, this is the rock that we encounter most of the time. It's formed from particles of sand, shells, pebbles, and other fragments of material. This is 90% of the rock that you encounter in your day. Igneous is formed from lava, right, or magma when it cools. It's usually smooth and glass-like, but sometimes it can have gas bubbles. Sometimes other things can happen so that it looks different. So here's some pictures of what these look like, right? So igneous rocks, actually, we'll start with metamorphic. Those are the first ones we talked about, usually ribbon-like, formed deep in the earth, right? You can kind of see what I mean by ribbon-like in this picture a little bit, but it's like a nice, smooth, dark, black rock. Also, marble is an example of a metamorphic rock. A lot of people have marble in their house possibly, or you've seen marble in people's houses. Sedimentary, like I said, is mainly the kinds of rock that you encounter every day, right? So rocks that you see outside and that you pick up are most likely sedimentary. Igneous rock is another kind of rock that people have in their house. Granite is a lot of times what people use for countertops in their kitchen, right? Quartz, you might even have seen. A lot of times people have quartz, like crystals. And then there's this other kind of rock here, pumice. This is when gas bubbles get in the rock, and there's just all these little air pockets, and it makes this little puffy looking rock. So there's a bunch of other examples. These are just a few, right? So, but just keeping in mind, there's 3 kinds here, 3 types. So the rock cycle is just a nice way for us to organize these types. Kendrick, stop. So basically what's happening, right, is if you follow this rock cycle at all, you'll see how the 3 types of rocks change. So metamorphic rock, when it's melted, it becomes magma, right, or lava. If that cools, it becomes igneous rock. And then look, igneous rock can melt, become magma, and cool, and stay igneous rock, right? Igneous rock can also get weathering and erosion happening to it, so being broken up over time by that water and wind, which can form sediments, right? If those get compacted and condensed together, you get sedimentary rock, which again can get eroded and weathered on its own and go back to sedimentary rock, right? Sedimentary rock and igneous rock, both when they have heat and pressure applied, become metamorphic rock. And metamorphic rock can become sediment if weathering and erosion get to it. Now remember, metamorphic rock is formed deep in the earth, right? So weathering and erosion is going to be hard. It's going to take a lot of time for weathering and erosion to happen to metamorphic rock, but it does, right? Because the earth is millions of years old. So there's been millions of years of weathering happening. Okay, so really the rock cycle is pretty easy just because it's 3 kinds of rocks and it's just shifting between them. So the way that I like to remember this is heat and pressure makes metamorphic rock. Anytime heat and pressure is happening, metamorphic rock is getting made. Igneous rock, I just like to think igneous is lava. Igneous rock is lava. Lava's melting and then cooling and it's forming igneous rock. And then sedimentary rock has the word sediment in it, right? So sediments are pieces of rock. Sedimentary rock is made up of tiny little pieces. You might be able to think of a better way to memorize it or think of it. But really, all you have to do is follow this graphic. So fossils, my favorite topic of these topics. So fossils are important because they tell us which organisms lived, when, and where, right? So if we didn't have fossils, we would have no idea what lived before us, right? We would be able to see all the animals that live now and all the plants that live now, but we would have no idea, well, what lived, 200,000 years ago? We wouldn't know. Fossils tell us that, right? Fossils show us, oh, these animals were around at that time. The interesting thing too is that 95% of the species that have existed on Earth are extinct, right? They're no longer here. So fossils give us a lot of information about that. Which species did exist and don't exist anymore. They help us understand evolution because of that, right? So fossils help us put together a picture of how organisms have changed over time. And then they also help us learn about the history and the age of Earth, right? What was happening in Earth during those times? And if we find tons of fossils, right, sometimes that can even tell us when something went extinct, We have a bunch of fossils, and then the next layer of Earth, there's none. Okay, that animal went extinct. So sometimes scientists are able to put together information like, oh, something happened here. There was a asteroid, there was a volcanic eruption, there was flooding, there was something that caused all these animals and plants to die. So when we're talking about fossils, we have to talk about this kind of a picture here, which is really all of it's like the geologic timeline of Earth. And I picked this graphic because I think that it's showing us two really important things. First of all, here's us up here standing on top of Earth, right? A guy with his car and is that a dog or a deer? I don't know. An animal, right? And then as we go down, we get older and older and older and older until we finally get to when Earth formed 4.6 billion years ago. And that's a great way to think about fossils, right? Is that the deeper you go in the Earth, the older the fossil is. So if we pick a fossil from down here, that's an old fossil versus if we barely dig in the Earth and we get a fossil, it's a newer fossil. So scientists have put together this timeline, and they've even organized into these eras and these periods of time of Earth, right, based on what was living. So for example, in the Mesozoic era here, we have the Cretaceous, Jurassic, and Triassic periods. Guess what? Jurassic, what do you think lived during the Jurassic time? Thank you, Giovanni. You're back and you're saying dinosaurs, right? It's called Jurassic Park for a reason, because the Jurassic period of time was when dinosaurs reigned, right? When they were the most prominent animal. And then they kept living. And then here there's this thing that says big, big extinction. There was a mass extinction that killed off a lot of species, right? There was another mass extinction down here. This was actually the biggest one. It killed 95% of things living. Very few things survived that extinction. So there are scientists who actually study. There's been 5 mass extinctions. They study those extinctions and try to figure out what happened. So they are pretty much in agreement now that the dinosaurs were killed by an asteroid that hit Earth. They found the crater, right? It hit right off of the coast of Mexico by the Yucatan Peninsula. And they found this layer of a special mineral called iridium in the Earth that symbols something from space hit. And they think that happened along with a lot of volcanic eruptions, and all the ash that was put up in the air made it so cold that tons of plants and animals died. They weren't getting enough sun. Right, so pretty interesting stuff. So basically there's all these eras here, and during each of these eras, there's different kinds of animals that were around. So we can connect this to the relative and the absolute dating. Relative dating is kind of what they've done here, where scientists just put the fossils in order, right, of who's oldest. So the deepest layer of rock has the oldest fossils. Over here, we have our absolute dating, where we find the exact number of years old that the rock is. Right, so even just a little bit into the Earth here, this was already 1.8 million years ago. Okay, so I thought we could look at some of these fossils. I want you guys, this is really hard, by the way, and I know that, but I want you to look at these fossils and see if you can figure out the order from oldest to newest, if you can even tell what some of them are. So we're just gonna spend like a minute looking at these, thinking about it, and then I'm gonna kind of tell you what they are. I don't even know the exact order, so I will tell you that. All right, so spend about a minute and a half looking at these fossils, figuring out oldest to newest. All right. So hopefully you had a chance to look at them, try to think about them a little bit. We're going to go into just sort of talking about them. Which one did you guys think was the oldest? You can tell me maybe like kind of what it looks like. I know it's kind of hard because you can't really point to it. Which one did you guys think was the oldest? First picture, top left, Giovanni says. That's a good guess. This one right here with this little plant looking thing. Okay. Snail one. So this one, Bonnie, you're saying is the oldest? Okay. So you're correct, Bonnie. And Giovanni, you're actually also kind of correct, right? These are some of the oldest plant fossils found. The hard thing about plants is that plants don't have bones, right? And they don't have shells. So it takes a lot for them to get fossilized. So these plants could have existed at the same time as a shell animal. We don't know because we don't always see plant fossils, right? It's a lot harder to get plants to fossilize. But this is one of the oldest recorded animals. Kendrick, come here. Stop. My dog is like a baby. He just cries and cries. Okay. So then we have these plants here. You didn't want to put in the plants. Yeah. Plants are too hard. I agree with you, Bonnie, because like I said, they don't always fossilize and plants really haven't changed that much. Like this kind of looks like a plant that you might see outside today, right? That doesn't look like anything crazy. So this fossil here that we're seeing in the bottom middle is an ancestor of the whale, right? So this is one of the first ancestors of the whale. Whales actually came from walking mammals that had legs, and their legs slowly disappeared, and then they were swimming mammals. So this is a whale fossil here. This guy here is one of the earliest amphibian fossils, right? So like a frog type animal. We also have a dinosaur, right? Which again, kind of hard to distinguish between the amphibian and the dinosaur, right? They could look like the same animal or lived at the same time. And then Bonnie, you were right. This is one of our ancestors here, a human-like animal down here in the bottom right corner. It even looks pretty human, right? The only difference is you can see this jaw is huge, right? The jaw would have come down a lot. So we don't have that big of a jaw. So this is one of the earliest human-like fossils that we found. So you can imagine that if you're a geologist or you're someone who's studying fossils or using fossils, it's pretty hard. Yeah, it does look like a monkey. So that's interesting, Emma, because a lot of people get confused when we talk about this kind of stuff. They're like, oh, humans came from monkeys. Okay, humans did not come from monkeys, right? We had a common ancestor. So this could have been our common ancestor that made two branches. One branch became monkeys. The other branch became humans, right? So when we go far enough back and we start seeing these skulls like this, they are going to look monkey and human-like because that could have been our common ancestor, right? So it's pretty interesting. It's also really hard work because I just picked some random ones here, but even just looking at them, you're like, well, I don't know. And that's why we need that absolute and relative dating. That's why we need to know when was it, like where was it found in the Earth's layers? We need to be able to test it to see how many years old it is, right? Because if you just show somebody a picture and you say, oh yeah, this is a human ancestor. Okay, well, I want to know how many years old is that, right? What if somebody found this and it's actually a modern day human, right? And they just had some kind of strange bone structure. So we need more evidence other than just looking at the fossil to be able to prove when something was around. Okay, so the last thing is what I want you guys to do post this session here. Sorry that this one wasn't very interactive. I tried really hard to make rocks interactive, but they're not very interactive. They also have some pretty cool lessons, actually, with some interactive stuff in the modules. So you'll get some of that when you're doing the lessons. Also, I just think it's interesting to hear about this stuff. So hopefully you felt the same way. So I want you to pick one period, a time period here from this list, right? There's a whole bunch of options. It also tells you what era it's in. I didn't want to explain all that, but there's tons of ways that they divide time, right? It's a little complicated. So I want you to pick one of these periods. We talked about how the Jurassic and Triassic and Cretaceous period, there were dinosaurs, right? So you might want to pick those if you're interested in that. Otherwise, just pick a random one if you're like, I don't know. And what I want you to do is research how old is that period, right? How many millions of years ago was it? Who lived during it? What kind of plants were there? What kind of animals? And at least 2 facts, right? So facts might be like the temperature was really, really cold during this era. Or facts might be this was the first time that an animal with bones ever existed, something like that. And I want you to include at least one vocabulary word, which should be really easy because one of the vocabulary words is fossil. And you can say, there was a fossil found in the Cretaceous period of this animal. And that's your vocab word, right? If you want to push yourself, try to use more vocab words. Try to talk about relative dating, absolute dating, talk about fossils. You could even talk about the types of rock, right? Fossils are usually found in sedimentary rock. So you could always include that. So if you want to challenge yourself, try to use 4 vocabulary words instead of 1. So I want you guys to email this to me by Monday. So that gives you a lot of time. You could do it right now while it's fresh in your mind. You could take a break, do it tomorrow, right? But I want an email with this by Monday. So I'm not going to be able to leave this up forever here. So remember, for those of you who missed the very beginning of this session, right, in modules, I already uploaded virtual session module 4 on 216. I already put the PowerPoint here. So as soon as we end this session, you can just go to the last slide. You could look through the other slides if you want. And right there is the instructions, right, and all the different periods. A couple of them are getting cut off on the bottom here. So if you really want to take some time here, you could even look up a couple of them and see which one is most interesting to you. All right, I just want you to have a little bit of an idea of what happened during different times of Earth. It's pretty cool. All right, so otherwise, we are done here with the session. If you have questions, please email me, right? Let me know. I'm going to write down who's here really quickly so that I can add your attendance. Okay, we got Bonnie, Carlo, Emma, Giovanni, and Alexa. Okay, so hopefully this helped you guys get a little bit of a big picture about Module 4, right? It is interesting just to hear about all of these different sciences kind of coming together, right? There's some biology in here, there's some geology, there's some earth science. So it's a lot of stuff meeting together, which I think is pretty cool to see that, right? That's how real science works. Rarely are people just like, I'm only a biologist and I never think about anything else. Okay, so thank you guys for coming. And our next thing is our lab on March 17th, St. Patrick's Day, if you celebrate or care about St. Patrick's Day. And we're going to be playing with bubbles, as I said. So look forward to that. Okay, so have a good day, everyone. Oh, that's your birthday. And we're going to be playing with bubbles. It's going to be fun. So I'll see you guys on March 13th. Or 17th, sorry. March 17th. Bye.